Hi, my name's Tarun Shome and I'm a Product Management Director within the BlackBerry Ivy Business Unit at BlackBerry. And I'm going to take you through and show you some of the use cases that we're demonstrating today on this Jeep Grand Cherokee. And this will show you the power of BlackBerry Ivy and how we can work with ecosystem partners to develop synthetic sensors that can provide meaningful insights within BlackBerry Ivy's runtime. So let's get into the vehicle and take a look. So, now that we're in the vehicle, I'm going to take you through the demonstration of the use cases that we've built up for this particular vehicle demonstration. And what we have here are two use cases that we've worked in conjunction with our ecosystem partners. We have Computex, who have created virtual sensors that they've now been able to deploy as synthetic sensors within BlackBerry Ivy. And Computex virtual sensors are able to determine tire wear, brake wear, and so on based on actual sensors from the vehicle itself. We can also show Car IQ's payment mechanism, where they actually use the vehicle as the payment mechanism rather than, for example, using credit cards and so on. And they actually use BlackBerry Ivy to be able to run their authentication algorithm within the vehicle itself rather than running in the cloud. So what we're able to do with BlackBerry Ivy is these use cases can be built within Ivy's runtime and run as synthetic sensors to provide insights to an Android application. And we actually have an Android application running on the in-vehicle infotainment system here that's running on a QNX hypervisor. We also have the cluster here which is running in QNX. And all of this is powered by Bosch's latest IDC cockpit controller. And we've integrated with that cockpit controller to be able to realize this demo that I'm going to take you through now. So if I go to the first scenario that I have, where I'm going to show you Computex predictive maintenance synthetic sensors. These synthetic sensors, or the particular synthetic sensor run by Computex, is running within BlackBerry Ivy's runtime, and it takes the signals from BlackBerry Ivy's hardware abstraction layer, and it's normalized. So these signals are normalized by BlackBerry Ivy and then presented to the BlackBerry Ivy edge processing runtime, and therefore to Computex synthetic sensor, which is going to then produce insights on those vehicle signals. And they're able to take these vehicle signals and actually use them to predict what the tire wear is going to be on the vehicle and the brake pad wear. And we can see the examples up here on the display. Now, we're also able, with Computex synthetic sensor, we're able to actually look at the particular driving profile. So whether you have an aggressive driving profile or an eco driving profile, we're able then to use that to predict what the future wear of the brake pads and the tires is going to be. And here we have a particularly aggressive driver, and as a result, that aggressive driver is going to see increased brake wear and also increased tire wear. Now, previously, all of that would have to be computed in the cloud, so the data would need to be sent up to the cloud and their complex algorithm would be run within the cloud itself. And of course, that would require a lot of data to go up to the cloud. So there are increased costs in terms of connectivity costs, cloud compute costs, cloud storage costs, and so on. Whereas by running it locally within BlackBerry Ivy's runtime, we can greatly reduce those associated costs and also the latency because we're running within the vehicle. Now what we can see here with this aggressive driver, we're going to get around 5,000 kilometers less than we would expect to get from these brake pads and these tires. And if I go to a predictive view, you can actually see all of the red and orange here, which is predicting that those brake pads and those tires are going to be worn in a very short period of time. And it's mostly down to that aggressive style of driving. But by showing on this Android application, based on the insights we're getting from the BlackBerry Ivy synthetic sensor, we can actually give the driver a little bit of coaching as well and encourage them to drive in a more eco-friendly mode to conserve the tires and also to conserve the brakes. So what we're going to see here is if they actually take that coaching into consideration, the driver here is actually going to slow down and they're going to take a more eco style of driving as their approach to driving the vehicle. And as a result of that, we're going to see decreased tire wear, decreased brake wear, and obviously then a longer interval between the next service. And again, all of that is provided by those insights from BlackBerry Ivy. And those insights are being ingested into this Android application that's allowing all of this information to be shown to the user. But those insights don't just need to be provided to an Android application, they could also be provided to another cloud application or a fleet manager's console view, where they would actually be able to take a look at the actual tire wear for all of their fleet of vehicles. So what you see here locally, they would be able to see on their console, their fleet console. Or the other thing is you could also provide those insights to a voice assistant. So in this example, if I say, Alexa, what's the status of my tires?
Okay, here's Ivy demo. Your tires are in a poor state. Please book a service appointment in 19,050 kilometers. I've sent you an email with different options.
And the voice assistant is actually not aware of this application because the voice assistant is taking those insights directly from the Ivy synthetic sensor. So again, it shows you that flexibility of being able to take those insights and do lots of different things with them, be it an Android application, a voice assistant, a cloud application, a fleet management console, for example. And the beauty of what we're doing here, by building these synthetic sensors out on BlackBerry Ivy, it greatly reduces the development time. The Computex synthetic sensor was built from their virtual sensor that they had running in the cloud, and it only took them around 5 weeks to integrate that into BlackBerry Ivy. So having that runtime and having the SDK available can greatly reduce that development time, but also the associated costs of being able to scale out these software solutions onto multiple instances of Ivy. We talked about reduced telemetry and data costs, and again, we've seen that by running locally. That gives us the ability to do that. We have complete control over the stack and how we actually deploy our solutions into Ivy's runtime. And we also have full ownership of data from the OEM side, from their console, of the provisioning, the policies and permissions, and what happens with that data. And then, of course, we saw these ecosystem developers such as Computex. We're giving full access to that Ivy developer community, so being able to take those synthetic sensors and deploy them into Ivy. And another use case I can show on Ivy that we have within this vehicle is where we could make payments within the vehicle itself. So you can actually take the vehicle and use the vehicle as a payment mechanism. And I'm just going to show you that now with a refueling use case example. But of course, this could be used for EV charging as well. And our partner is CarIQ Pay in this instance, and they're taking vehicle signals and they're using that within BlackBerry Ivy's edge processing to run their synthetic sensor, which is using a machine learning model to fingerprint the vehicle. So we take the uniqueness of the sensors on the vehicle to really fingerprint it and authenticate it. Now, why is that important? Well, if we're going to use the vehicle as a payment mechanism, the last thing we want is fraudulent payments to be charged to our vehicle. So for example, if someone spoofed the VIN number or something like that. But by having that constant authentication here, that's not going to happen. The other thing is that constant authentication means we're not having to send data up to the cloud because it's happening locally on the vehicle. The synthetic sensor is also fuel aware, so we know when there's a low fuel warning because that's being fed up as vehicle data into the synthetic sensor. So when there's a low fuel warning, we also have geolocation data coming in, so we can actually direct the user to the nearest gas station that's actually a partner with CarIQ. So we can actually make that vehicle payment at that gas station. As we see the vehicle entering the forecourt of the gas station, we can prompt the user to park at the pump and switch off their engine and put the vehicle in park. So minimal interaction from the user with this use case. They don't have to present a credit card, they don't have to put a PIN number in, all of it's charged to the vehicle. And again, that's with the authentication that we have that's running locally within BlackBerry Ivy's runtime, rather than sending huge amounts of data up to the cloud. When the user puts the pump number in, the only thing we do over the cloud is the authorization with prepayment through Visa, CarIQ Pay's partner, and we're able then to unlock that particular fuel pump. In this case, this is with a partnership with Shell. They have a partnership with Shell across North America. Fueling can take place, so the user can just refuel once the pump is unlocked, and that is charged then to the vehicle, and the driver can just replace the pump and drive away. So minimal interaction. They then get an electronic receipt delivered to the vehicle, but that could also be delivered, for example, to the fleet manager. And if you think about it, we can take these use cases and even combine these two example use cases that I've shown you here. Think of examples where a fleet manager could look at the tire wear on their vehicles, their fleet of vehicles. They could look at the brake pad wear on their fleet of vehicles, and then they could pre-authorize a payment through Car IQ that's charged to the vehicle to allow their driver just to drive in, replace the tires, replace the brakes at a service center, and get that charged to the vehicle. So that gives you another example of how we can combine these use cases and how we can actually use them as a feature of what we have with BlackBerry Ivy. And I hope this has given you an insight into some of the use cases that we can realize with BlackBerry Ivy and how easy it can be to develop on our platform. Thank you.